Well, good afternoon, everyone, and welcome back to our second session in this series of Bite Sized Corrosion. We're focusing on coating gremlins, and we're going to be focusing today on some of the documentation gremlins that we encounter. Yesterday, we started a discussion about some of the gremlins that we as engineers can encounter associated with the coating aspects of our engineering projects. And yesterday, we started by looking at documents which we refer to, but over which we have no control, documents of external origin, particularly the standards like ISO 12944 and also product data sheets associated with the coating that we think we would like to have used on the project. But within our project, we really should have a project-specific specification. And based on that, our contractor should develop a quality control plan that speaks to this project and not some other project. And those are the two aspects we're going to zoom in on today and look for some of the pitfalls or the gremlins associated with that. Today, we're welcoming Gert back into the hot seat, and we're going to be tackling project specifications and QCPs.
Thank you again, Vanessa, and everybody for joining. And looking forward to our discussion today.
So Gert, yesterday during our discussion on standards and data sheets, you alluded to the importance of a project coating specification. Now, sadly, my experience has been somewhat that engineers often roll out the last tried and trusted specification. What would you say is the major problem that we might encounter with that?
Well, Vanessa, the way that you put it is actually very accurate. I like to refer to it, and a lot of my other colleagues as well, as a walk-by specification. As it sounds, it's literally that. It's the engineer or the specifier walking out of the office on his way to the site meeting, and he decides to take the old trusted specification that he used in the past. And is it applicable? That's the problem. It might not be applicable for the task that's at hand. Problem is that the alignment of that specification could be completely different, and it might only talk about maintenance and not about a new project, or vice versa, and therefore it is not applicable.
So I said at the beginning we should use a project-specific specification, and I guess that needs to detail the scope of the project so that you know that we are talking about maintaining this coating or applying a new coating to the new structure.
Most definitely. And as we mentioned in our previous discussion, unfortunately, we do have those field chemists that are out there, and they use the specification, and because they've been in the industry for many, many years and have experienced certain products that work very well, they're uninformed of the new stuff that's out there. And because they're uninformed of the new stuff that is out there, they might say, you know what, thicker is better. So let's put on the inorganic zinc at 120 to 150 microns, thinking that, yes, most definitely what we are doing now is we actually giving a longer lifespan. So we've put that sacrificial coating on, and it's going to protect the structure for longer. But if you go out in the product data sheet, and like we mentioned, the importance of that product data sheet, thicker is not better. If you put it on too thick, we can get cohesive failure occurring in that actual coating, and it's because it's the first line of defense, if I can put it that way. It's the first coating that's placed on the pipeline. You can have cohesive failure, you can have a complete adhesive failure of that coating, and it's just going to fall apart. So yes, it has to be specific to a new project if it's going to take place.
And also, if they'd done their homework, they'd looked at that coating thickness of 120 microns and compared it with the product data sheet, they would have seen that the product data sheet will give a maximum coating thickness for those very reasons.
Correct. So you're not just talking about the thickness. The specification then has to now talk about the profile. Is the profile applicable to the actual coating that's being applied? The specification might mention a different type of a profile compared to what the product data sheet refers to. So it's very important that they have the acceptable levels of cleanliness. They talk more not just about the actual thickness, but how clean the surface needs to be before the coating gets put on.
We'll talk about cleanliness and applying our coating adequately thickly and so on next week. But in terms of the specification, I think it's important that we realize that the specification needs to detail these various attributes very clearly so that we know what the acceptance criteria are, and so that we know there's less ambiguity when it comes to having the argument about who's right.
Most definitely. You see, and sometimes the specification is a little bit vague, but you could have a specification that simply refers to the product data sheet. The specification has a single line item that says refer to manufacturer's data sheet for all of this other information, knowing that those chemists have gone that route already and they know what's going to be the best for their product. So the specification is almost like the guideline that there needs to be followed. The specification is your roadmap for your specific project that you do. You know, you can't skip it down when you're driving.
So what would you say are some of the key things that should be in the specification, that if I, as an engineer who knows very little about coatings, and I just want to make sure that my specification is addressing the key components, what would you say the key aspects are that the spec should include?
I'd like to start off by actually mentioning it. I don't speak specification. We speak English. And unfortunately, you get specifications that are written at such a highfalutin level that they lose the actual roadmap. The people get lost because they don't know where to go. So basically, a well-written specification needs to navigate you through an easy way to get the project done properly. And it's typically broken up into 3 different parts. You can have your general part, which is speaks about the scope of work, maybe referencing some standards. Then you've got your materials section, which might be various different materials that gets used on that project, not just specific to coating. It might be specific to repairs on certain areas. And then last but not least, the execution of it. How are you going to go about taking that product and putting it on top of the surface? That execution portion is very, very important, because that's where the contractor and the engineer knows what's the surface preparation, how are you going to assess that surface preparation, what are the environmental conditions, you know, what's the limits, how hot am I allowed to go, how cold am I allowed to go, what's my relative humidity supposed to be like. Then we look at our dry form thicknesses. Dry form thickness can be referred back to the standard, which is the 12944 standard, which again has a table set out for the engineers to quickly reference to say, right, this is the thicknesses that will protect the structure for that period of time if the environment is a C1, C2, C3 or C5 or whatever it might be. And then last but not least, a section that is very important in your specification is the inspection. What are the inspection points and how are you going to go about doing those inspection points? It's very, very important.
So if I've got a specification and I make sure that under the general section, it defines the scope of my project. Under the materials, it talks about what structures are needing to be coated and also what products are suitable. And under the execution, it's covering all the aspects that I've also seen and that we discussed yesterday in our data sheet. I'm pretty confident that we've got something that should be able to withstand any kind of attack, whether it be from a vigorous contractor or even in court.
Correct. You know, and if your scope of work is very vague, that makes it very difficult. And you're talking about a legal issue now. Legally, if you look at how the scope is written, a lawyer will find the loopholes. We all know that. And if the scope is vague by saying use a high quality paint, you can go into the argument, what is high quality paint? You know,
your definition and mine are different, yeah.
Correct. You know, or if they say you need to paint a tank, what is the tank? Is it a buried tank? Is it above ground tank? What is it manufactured from? Is it stainless steel? Is it carbon steel? Maybe it's a fiber tank for that matter. Are you painting the inside of the tank? Are you painting the outside of the tank? You know, so it's got to be very specific as to what the actual item is that you're doing. And then when you go to the other sections in your specification, they must not be vague. It must be clear enough so that the contractor and the engineer knows exactly what to expect.
I think the important thing that's coming out for me is that if your specification is well written, then there's no confusion either on the part of the engineer or of the contractor what needs to be done, when, where, why, how. And that should clear up some of the challenges a little later. And in fact, even from a costing perspective, because sometimes the jobs that are put out for pricing give such little information that one feels for the contractor who just doesn't have enough information to be able to supply a competent bid. And then I guess I thought that, the cheapest paint was high quality enough, and therefore I've priced on that, becomes quite different to a very high quality, heavy duty coating, which not that I can pick up in the local hardware store, but that I actually need to contact the suppliers to lay my hands on. Definitely a gremlin that engineers can think of in how they can eliminate some of the challenges on the costing side is by ensuring that their specification is well balanced.
And a contractor is obviously going to want to do the cheapest work out there because it's more money in his pocket. So if the product data sheet, for instance, refers to a certain type of cleanliness to be used, but the specification calls for a higher cleanliness, the contractor is going to want to do what the product data sheet says because it's going to cost him less. That's where the specification then becomes overruling the other documents to say, no, we've done this before, we want a cleaner surface, so therefore you need to stick to it. And if it's vice versa, it needs to be brought to the attention of whoever is the specifier that the product actually requires a cleaner surface.
I was just going to say, it's important that if the data sheet requires a greater standard, that is addressed by the engineer, that the specification is updated. Because at the end of the day, the important defining document is going to be the specification. I guess just to digress slightly is that this also clarifies why a kickoff meeting is so critical, so that you can clear the air. And if everybody attends that kickoff meeting well prepared, they actually are familiar with the specification, they know what the expectations are, that should, I think, maybe even be mandatory in the specification. I know it isn't, and I know that some of the coating inspector training courses recommend it, but maybe we should start to get a culture of insisting on a kickoff meeting so that everybody really is speaking the same language. You said you don't speak specification, neither do I, but if we all sit around the table, we can determine how we are interpreting this specification language.
Correct.
So that we are literally all on the same page.
Yeah, we typically talk in some of the courses that we do about getting a good understanding. If your specification mentions something, for instance, like there must be sufficient light, in one person's mind, the light might be a lighter. It's a flammable lighter. It supplies light. Whereas another person is thinking about 40,000 lumens that's going to blind somebody on the moon. So you need to clarify these things so everybody is on an open playing field, knowing this is what we require before it starts. And you quite rightly mentioned, if a kickoff meeting is called for, it should be timeous enough for people to study that specification so that they can go and do it. And it comes back to my thought about the walk-by specification. You don't want to hand the specification at that meeting and say, right, we're starting the project tomorrow. It needs to be handed out timeously, most definitely.
I think the other document that can cause problems is the quality control plan that the contractor submits. And this is often a contentious item. And I think it would be worthwhile spending a little bit of time now talking about some of the concerns, some of the common mistakes in a QCP or quality control plan. And the QCP, if I'm right, is usually generated by the contractor. Am I correct?
Yes. Typically, the contractor is the person that now has been a successful tenderer and he's successfully got this contract. So he'll then take the specification and the product data sheets, and from those two documents, he'll draw up a quality control plan, which is a step-by-step what is going to be followed and when are we going to stop so that we can do certain inspections. So it's definitely drawn up by the contractor.
So continuing your analogy of the roadmap, if the specification is the roadmap, then the QCP is sort of the detailed itinerary. It's all very well that we've got to get from Bloemfontein to Johannesburg via Kroonstad, but we also need to stop and refuel at this station, and we need to check the tires at this location, but actually detailing those steps along the way.
Most definitely. So therefore, you've got all these hold points that needs to be clearly identified in the actual quality control plan, because now these are points that we need to get together so that we can get consensus. Have we met the requirements of the product data sheet? Have we met the requirements of what the specification gave? Are we using the correct testing method? And everybody signs off on the document to say, right, we're happy up to here. Let's now go to the next step. So I think it's also very, very important for the success of the project that these QCPs be reviewed by somebody that's got a lot of experience in working with quality control plans to be able to identify, hang on guys, we've missed a step here. Here you talk about environmental conditions, and then your next step says blast profile, and your next step says that you need to now put your paint on. Where are we testing for the visible and non-visible contaminants? There might be dust on the surface, there might be salts on the surface, which can cause a failure further along the line. So surely we need to include it, because that's what the spec actually called for. So it's important that this gets reviewed.
And I think also I've seen a number of QCPs, and some of the more comprehensive ones, or the better ones, also include the reference documents. So it's not just, for example, you're doing the surface preparation and you want to check the surface is clean enough to whatever level, but also what it is being checked against, where the applicator or even their in-house inspector can go to get confidence that he's checking the right aspect.
Yes, most definitely. So those references, as our discussion was yesterday, will refer to the standard and maybe to the referencing document, which will be the specification. So the spec will call for the standard. Now you've got to double check it. Is it the correct standard? Am I using the latest version? And so forth. So it's very important that it does reference the actual document.
If we just run through a QCP, what are the kinds of things that should be referenced on the QCP?
Well, typically you can start off by saying, am I using the material? So there was material specified, and the specification might have been written 5 years ago, but the product has changed. So is it still the correct product that I'm using? So correct materials, definitely one of them. Then how clean must the surface be? How am I going to test for the cleanliness? Is it a visual assessment only, or is it actually a measurable? We talk about qualitative versus quantitative testing, if we can put it that way. Being qualitative, just saying, yes, it's clean. How clean is it? I need to compare it against the standard to say, this is how clean the surface is. Then how rough must the surface be? Here we talk about profile or anchor profile. Again, you can now refer to the product data sheet or to the specification to say, for this paint, I need it to be at this roughness for the coating to actually adhere. Surface contaminants. Soluble salts is one of the very key things that a lot of times causes osmotic blistering. Unfortunately, the coatings that are out there are all permeable. So somewhere along the line, moisture and oxygen will diffuse through the coating, and it can cause an actual failure to take place. So have you tested for those things? And that's typically the big one that gets left out on a lot of QCPs, because you don't see it. It's non-visible contaminants. Then the environmental conditions is very important. Yeah. Am I at the correct relative humidity? Some coatings require high moisture for it to cure. Therefore, you need to now actually accelerate it or put it in an environment that is wet enough for the coating to absorb the moisture into it to cure, for that chemical reaction to take place. How do I apply it? Can I apply it with a brush? A lot of times they say, yes, the stripe coating needs to be done. Are you going to stripe coat inorganic zinc? Can you stripe coat inorganic zinc? Those are the type of questions that you can then ask. How thick do I put it on? Now we come to our dry form thickness testing. And again, referencing a standard. How am I going to measure the dry film thickness? Am I going to use it from a smooth surface, or am I going to use an abraded surface? Am I measuring above the highest peak, or am I just measuring the total coating thickness? Overcoating times. Am I adhering to those overcoating times? Certain coatings need a long period of time to cure, some of them up to 7 to 10 days. But unfortunately, you get the pressure and they say, I want to put this item into production yesterday. So we're putting the next coat on, and that's where these failures going to occur. But it would be outlined by the product data sheet to leave it for that full cure to take place before putting on the next coating. And then obviously, we need to then look at the different areas as we're going through this QCP. Where do we want critical hold points? Where do we need an inspector to come in with the coating representative, with maybe the owner's representative, to look at the steps to say, are we happy that we have followed what the specification has actually required? And this is where we actually sign it off to say, we're happy with it. Now you can continue putting this into a serviceable environment.
There's another challenge which I think that the engineers need to be aware of, and that is when the coating contractor requests a concession or a change. It always worries me. We've gone to a lot of trouble. We've consulted the relevant standards. We made sure that the correct data sheets were available. We have a wonderful project specification. We made sure that the QCP is answering all of those questions. And then halfway through the project, for some or other, probably very valid reason, there's a request for a concession. And my concern with this always is it's all very well to give the concession, but what are the possible ramifications? And I think it needs to be extremely carefully considered, because often there are hidden challenges or hidden gremlins that we may not think of on first reading the concession request. What is your feeling in that regard?
Well, using the analogy again of the roadmap, you can take a detour off your roadmap and maybe take a dirt road. Your GPS told you turn left here, and that's almost like your concession. But is it the correct route to follow? It can lead to other problems down the line. So contractually, you need to try and stick to the specification rigorously. You know, that is what needs to be enforced and what needs to be stuck to. And if any concessions are made, it shouldn't be made for shortcuts. The contractor can get the work done quicker, or the project can get online quicker, because that will lead to failures down the line. So I think I agree with you that there are lots of ramifications if you actually make changes to any type of specification, and it needs to be clearly discussed and laid out on the table so everybody agrees why we are doing it before just saying, yes, let's go ahead and do it.
And I think you alluded to something there. Very often concessions requested when there's time pressure on a project. Yes. And for me, in many ways, time pressure is probably the biggest gremlin. Because when we rush, whether I rush getting ready to go out, and then I end up being silly on the road and maybe having an accident, that lovely Afrikaans expression, goedkoop is duurkoop. We're wanting to get it done very quickly. We're wanting to try and meet the deadline. And if we just allowed ourselves to do it appropriately or properly, we would end up with the best possible solution for the project. And it's so tempting to take that shortcut, or to rush it at the end, or to accede to the client's request for an earlier deadline rather than the deadline that was initially agreed. And all of that really can end up being the very duurkoop, the very expensive result to the process.
Most definitely. You know, the saying also goes that, you know, there's never enough time to do the work properly, but there'll always be enough time to do it over. And I think what people don't realize is how expensive it is to do rework. Rework is very, very expensive. And if that was because of shortcuts that were taken, there are going to be costs involved, and it can sometimes even double the cost of a project.
Gosh, thank you, Gert. I think we've covered a lot, and it's a lot of food for thought today. And almost like everything in life, we seem to have asked more questions than we've provided answers. But I hope that as an engineer listening in, that you feel that if we've not answered your questions, at least we've raised further questions that you can ask when you're involved in your construction project.